Hi and welcome to Introduction to Structured Programming.
Hi, also from my side.
Yeah, I'm here together with Lucas, same as last week. And yeah, we are looking forward to today's content, which will be mainly focused on functions. So we've mentioned it several times already last week. All a function use different things with functions. And yeah, today we will finally have a look at them. Yeah, the first question to the chat is, please let us know if you can hear us. The setup is working. Yeah, thanks for your feedback. Perfect. Then let's start again with the organizational matters. And yeah, we have quite a few things today to mention here. First of all, the coding sessions. So coding session 1 has opened, so the homework is available in Teach Center. You can download it and you can do it. And you should follow the following procedure if you want to get points for the coding session. So first of all, you should register for a session slot in Teach Center if you want to get points for the first coding session. And this has to be done until the 19th of October. Once you've registered, you can then complete the homework. It's available in Teach Center at the registration. Then you should submit your solution in Teach Center. Here it is important to submit it before your actual coding session starts. And after that, you just have to attend the session, participate actively, discuss with other participants, and at the end, just do the reflection quiz again in Teach Center. So that's all for the first coding session. It's the first out of 3 in this semester. And we also release assignment 1 today. So it's the first of 4 assignments. We'll hand it out after the lecture, so at 7 p.m. And there will also be an announcement on Discord with all the important information, so how you can access the assignment, how you can work on it, but also how you can submit it. For example, this has to be done via GitLab. And also quite important is the deadline. It's the 29th of October, so today in 2 weeks at 6 p.m. And yeah, the submission, and in general, you should work with GitLab, with your GitLab repository, which will be given to you in the next couple of days. And of course, we also have the weekly exercises. So we are currently in week 3. These weekly exercises are the last weekly exercises that count towards assignment 1. And again, as a short reminder, if you pass less than 50% of all the weekly exercises that belong to assignment 1, you would get a point deduction of 25% for assignment 1. So make sure you work on the weekly exercises and do them and submit them before the deadline of day 1. All right, that's everything related to organization. And now we can already start with the recap. So last week we talked about conditions, but also loops. So in general, how we can control the flow of our programs. And for that, we have prepared one quiz here. It's a bit longer, more lines of code, also many conditions here, even nested conditions. So we have an if inside of an if. And your job is now to guess the output. Again, you can join the quiz by scanning the QR code or by visiting slido.com and entering the access code. So take your time and go through the code and then choose one of the provided options. So again, we have a lot of operators here, comparison operators, but also logical operators. we want to know what exactly is printed.
Yeah, I see an answer in the chat, so please use Slido to answer and not the chat in this case.
Already over 100 answers, so let's wait a few more seconds and then we will take a look at the correct answer. Okay, so what is printed in this case? Okay, yeah, interesting. Most of you got it right. It's 0.10, which is printed. Also an option is 0.15.
Yeah, obviously almost head to head. Now it gets a bit clearer, but why is that? So maybe let's have a look.
Let's take a look at the code. So we have three variables here: purchase amount, customer type, and discount. Three variables with different data types. And let's take a look at the first condition here. So we have purchase amount is greater than 100. Yes, that's the case. Okay, so we will enter this block here. And once we are entering this block here for the first if condition, we can just skip this part here because we will never reach it once we are here in this part. The next condition is customer type equals C. Okay, obviously C is not the same as B, so we don't execute the statements here, but we continue with the next check, which is an else if customer type is the same as B. Yes, that's true. And we would have another condition here, which is purchase amount less than 200. Yeah, that's not the case. But since we have a logical OR operator here, so the whole condition is true once one of the subconditions are true. And since this is the case here, so this part is true, this part is false. In total, this is true. And that's how we know that the discount is 0.10. And that's how we get 0.10.
Yeah. I think the little trap here in this example is that after we have finished this if block, this else if block is not evaluated. And I think this is the trap here because this would be true for sure. And then we would go into this else if block and then the result would be 0.15. But since the first if condition is true, we just execute the if block without going into further else block or else if blocks. This is, let's say, the little trap in this example.
Yeah, thank you for the additions here. Once you're entering one block, you're not able to enter any other else or else if block anymore. Okay, as I just saw the question here, what if instead of the logical OR operator it was an AND operator? Then this whole expression here would evaluate to false, and discount is not assigned a new value anymore, and it would be 0, 0. All right, then let's continue with the next question. So we have a few statements here regarding loops or keywords related to loops, and you should now mark all the correct descriptions. So it might be possible that multiple answers here are correct, so take your time and read through them properly. Let's wait a few more seconds.
Yes.
I like the third statement. Do while always prevents an infinite loop.
Let's see whether this is true or false.
Okay, then take a look. And again, great. Many of you got the two correct statements. So break immediately exits the loop regardless of the condition, and continue skips the remaining current iteration. Maybe why are the three other statements not true?
Yeah, let's see. So the next one would be for, the for loop. Only one variable can be updated in the update expression. This is kind of tricky because I think we didn't mention it so far, whether this is possible or not. But I think we will go into detail about this. And then we have something about the while loop. There is at least one iteration before the condition is checked. This would be true for the do while loop, but not for the while loop. So if the condition in the while loop is false at the beginning, we never enter it, and so it's never executed. And for the do while, yeah, always prevents an infinite loop. This is for sure not the case. So yeah, only the first two are the correct answers.
Yeah, thanks so much. And we will now have a little bit of fun with for loops. So some of you take the answer that a for loop can have multiple statements in the multiple expressions in the update part, and we will now have a look at it, why this can be the case, why we can have multiple expressions, but also why we can leave or omit every part in the for loop. So we can omit the initialization part, which would be here beginning. We can also omit the update part here between the two semicolons, and we can also omit the update part at the end after the second semicolon.
Okay, but what happens if we do like this? So how often does this for loop execute?
It will actually run forever.
Okay.
Until the program is terminated, stopped, the computer is shut down. But until that, it will print infinity all the time. So this will run forever actually, and there might be some use cases, but usually we wouldn't write a for loop like that here. But yeah, we can also have multiple update expressions here. So we can have, for example, ++i, and then comma separated, just another expression minus j. We could have even more expressions here, all separated by comma. We can have an arbitrary number of expressions. That's totally fine. That's valid. That's valid syntax in C. But again, there might be some special use cases for that. But in general, we will just have one expression.
In most cases, yeah.
But it works. So it's valid C code. It compiles. That's totally fine. But as a general note, especially for ISP, for this course, is that please use or do not omit any of the three parts in the for loop here. So try, if there is not a particular reason for that, to have an initialization part, a condition part, and an update part here. Because if you omit it, the code will get really difficult to read and to understand, and yeah, this can lead to some errors that no one of us wants to have. All right, so we had some fun with for loops, and now we'll come to one computational thinking skill that's crucial for every computer scientist, and this is now called divide and conquer, or just decomposition. And we had fun with for loops. Now we'll have fun with Super Mario. I played it a lot as a child.
Me too.
It was a great game. It's still a great game. But we will now have a further look at how we could decompose Super Mario Bros. To finally get to functions. But first of all, let's just decompose it. So, as many of you have played Super Mario Bros., you have a lot of different game elements and something, for example, to level up, something to interact with, can be an enemy, but can also be a good thing. And what else do we have? We have coins to collect, things to jump on, whatever. Now we want to find things in Super Mario Bros. That we can abstract, so that we know, okay, these are elements that share something they have in common. And now let's take a look at the game elements that we could decompose. So we have a lot of different types of elements. We could have some elements that are moving, some elements that are static, some elements that are you can interact with, some elements you cannot interact with, some that have some advantages and can help you, some that may not help you, have some disadvantage. And these are elements that we can somehow group together by their behavior or by them objects. All right, now let's take a look at some game elements that we can group together. For sure, there is Super Mario. It's a playable character, so it's something that we can work with, something we can play with. We also have power-ups, for example, the flower. It's something that brings us an advantage, but of course there's also something else. It's the enemies that are maybe not our best friends in the game. We also have things that we can interact with. So the map, for example, we can jump into the pipe, but there are also things that we cannot interact with. They exist, but we cannot do anything with them. And of course, there are also other things like collectible items. So for example, we can collect coins while playing the game. So these are roughly a few game elements that we can decompose when we have a look at Super Mario. And we will now find out why this is important. For example, let's take a look at Super Mario as a playable character. If you want to play with Super Mario, what are some functionalities that are required to be able to play with it? Add your suggestion to the chat if you have any functionalities that you think are important for playing Super Mario.
I think that most of you are familiar with this game. Yeah, nice suggestions already.
Yeah, we have a lot of suggestions regarding moving around, so walking to the left, to the right, but also jumping. So that's definitely one thing. So we want to move an object. In this case, we want to move Super Mario in a two-dimensional space, the left, right, up and down, but also we want to increase the coins. Also check for collisions between two objects, and when we check for a collision, again, we want to distinguish between is it something good or is it something bad, and at the end we want to know if we reach the goal, if the level is over, otherwise we would play technically. All right, now let's take a look at how we could implement the move function. As many of you suggested in the chat, we will need to move to the right, move to the left, but also move upwards and downwards. So these would be 4 functions if we would program it again. So we'd have a function to move to the left, move to the right, move upwards, and move downwards. So that's a great example for decomposition, for decomposing one, say, huge goal or huge problem we want to move. And we can now decompose this into 4 sub-problems by defining, okay, we want to move to the left, to the right, upwards and downwards. And by decomposing it and providing a solution for the sub-problems, we can now solve the big problem, which is moving around. So this would be one example for decomposition and for creating functions to solve a problem. And of course, that's not the only functions that we have to implement to program Super Mario. We also have a lot of other functions, and we will have a particular look at the increase function.
Okay, so this was a very nice breakdown so far of the game Super Mario, and we've seen many different functionalities, and also within one functionality, the moving, we've also seen different sub functionalities. And regarding this increasing the coins functionality, we now have a detailed look into it with functions in C. So how can we implement this in C? In general, a function looks like this. So we have a function name or identifier at the beginning, and then we have 1, 2 or more parameters that we can define so that we can pass the to the function, and then the function can work with these parameter values. But there are also functions without any parameters, so it could also be 0 parameters, and I think all of you have already seen and worked with functions that have just 0 parameters, which is, for example, the main function you've used until now in every program. But the parameters also have data types, so I have to specify of which data type the parameter is. So in our case, we want to pass an integer, the original points, and we also want to put additional points to the function so that the function then can combine or add those 2 values to get a new value out of this calculation, which is then the new amount of points Super Mario has. Then in the function body, we can do our calculations. So in this case, we want to do a simple, we want to compute the sum of the original points and the additional points and store the result in the original points variable, for example. Then we also need some mechanism to return the result of our calculation to the caller of the function. So whenever we call the function to increase the points, then we want to get back the new amount of points as a result. And we achieve this by using the keyword return at the end of the function. So with return and then a value, in this case the new value of the points, we return this value to the caller of the function. And yeah, this data type of the return statement has also be the same as here on top in the function declaration, where we also have to state which data type the function will return. So in our case, we want to return an integer because we will add two integers, which will result in an integer. So we return finally an integer, and this is also stated here, the return type.
May I ask one question here? Since we are only having data types int, do the data types of the return type and the parameters always have to be the same? Can these be different?
For sure, this can be different. So in our case, it just makes sense to work with integers because we have no floating point values for points in our Super Mario game. But for sure, it could be the case that we have one float, one double, one integer, and we return a character, for example. If it's a use case for this, we could also do that. Yeah,
that's great.
Sure.
Yeah.
Okay, so in general, our syntax looks like this, as we've just seen in this specific example. And yeah, why do we do this? Why do we use functions? So the first advantage is that it makes our code reusable, meaning that we just write our function, in our example, the increasing of the points, once in our program, and then we can call it whenever we want an arbitrary, we can call it whenever we want from everywhere in our program. So we can reuse it, and if you think of Super Mario, you know that your points are increased every time. So we won't just call it once, so we will call it almost every time during the game. So we will use this function very often. So this is one great advantage to use function. The next one is the maintainability. So if I want to update something in a calculation that is done in a function, I can do it at just one point in the code in my program, and then it gets updated for all calls of this function. Also, the readability is better because if I make my code structure like I put functions for every sub-functionality of my game, then it's very clear, structured, and better organized, and and therefore we have a better code readability. And also abstraction is an advantage because we can do some complicated calculations, some complex logic within a function behind a simple name. And the name of the function often suggests what the function does. And whenever I call this function, I just need the name of it, and I know I get the result back. But how this is exactly done and how complicated it is, that's not really important for me as a caller whenever I use this function. So I can hide those complex logic behind just a name, which is then the function. Furthermore, a function should also do only just one thing. So if you think of this sub-functionalities of the moving left, moving right, moving up and down, and so forth, we should separate this into different functions so that each function just does only one thing and not multiple things. And also, we should think of a name that makes clear, if I just look at the name of the function, what this function does without looking into detail what the code does within the function. And also there should for sure be no side effects, so that the function just does this what it should and nothing more. Okay, so let's have a look how this function now could be used in our code. So we have a main function here, and we see a points variable, some print statements, and also here that we call our function in this line here. So this is a function call, and whenever I want to use my function, I have to call it this way, meaning that I use the name of it and I pass arguments to this function. these are the values that the function then uses with its parameters. So the first one would be the original points, and the second one would be the additional points. And in our case, those 2 point values would be added, and then the result of the function would be, in this case, stored into the points variable. So the points variable is updated by this new value that gets returned from the increase points function. Yeah, and here we again have our increase points function, which is the same as 2 slides before. Yeah, but how does the main function know about the increase points function? So if we just have a look here, the main function comes to this point and we call increase points. But how does the compiler know what increase points is? So we have 2 options here. The first one is that we put the function before the main. Then when it comes to the main, the compiler already knows there is this function increase points implemented before the main. Or the second variant is that we use function declarations, meaning that we just tell the compiler that a function of this name exists and it's somewhere implemented. This could look like this, that before the main function, we do this function declaration by just saying it's a function called increase points. It will return an integer value and it has 2 parameters of the data type integer. But the implementation of the function is not done here. This is just the function declaration. And then if it comes here to the function call, the compiler knows, yeah, there must be this function. And the implementation can be done somewhere below the main function. So this would be the second option to use function declarations. Okay, then we also have this return 0 statement here in our main function. We've now learned that return returns the result of some calculation or whatever of the function to the caller. So in this case of the main function, the return of the main function returns the value, in this case 0, to the caller, meaning that, yeah, for the main function, the value of the return statement is something like a status that says the program ran, was valid or it was invalid, or there were errors or some critical things. But if it ends with 0, so if the main function returns 0 at the end, everything was okay. Easily said. So this is just a short description about what the return of the main function does. Yeah, so but in general, a return statement exits the function and it sends the value back to the caller. And the data type, as we've already mentioned before, has to match with the one specified in the function header. In this case, we return an integer value in the increase points function, and here it's also an integer that we return from the main function. Yeah, and what happens with this value, as already mentioned before, the increase points function returns this calculated value, and then in this case it gets stored in the points variable. But I could do any other stuff with it. I could, for example, just print it out. So I could also call this increase points function here directly in the printf without storing it in the in the points variable, for example. But in this case, yeah, we use the value to store it in the points variable and then go on using this points variable. Okay, then there's also a keyword that is void, meaning that a function has no return value. So this is the case when a function does something, for example, printing something out, but does not really return a value at the end. So the function does something, but doesn't really return something to the caller of the function. then we use void, and then there's no return statement needed, because at the end, nothing is returned to the caller. No data, so to say. Yeah, let's come to our next Slido quiz. So we have prepared this short code snippet with 2 functions now. And yeah, let's have a look at it, and then yeah, tell us what you think what the output is by answering it in Slido. So the first function is called swap, and it takes 2 integer parameters, and its return type is void, obviously. Then it does some calculations, and in the main, we have 2 variables of the type integer. We call the swap function passing x and y, and then we print the values of x and y.
Okay, so we should have the values 15 for x and 10 for y at the end.
I think this would be the idea, right?
Yeah.
So to swap those 2 values.
So wait a few more seconds and then we will reveal the correct answer. All right.
Okay.
Wow.
Almost head to head again for all 3. Interesting, yeah.
And a compiler error.
Okay.
Maybe while you can explain why it is 10 and 15, leave a message in the chat, if you're in the chat, why you think it is a compiler error.
Yeah.
That'd be quite interesting.
Okay, so obviously the right answer is that the values were not swapped at the end, so they basically stay the same. But why is that? The problem is that we pass those 2 values to the function swap, but what happens here is that the value of x, which is 10, and the value of y, which is 15, are copied and then stored in those 2 values. So they are also called x and y, but this is just a coincidence. This does not have to be necessarily like this, so they could have any other name, those variables. And as I said, those values are copied into those variables. And then within the function, we do this swapping, which works right within the function. So we have a temporary value where we store x, then we store y in x, and finally the temporary value we store in y. So in this case, x and y, so this x and this y is swapped at the end, but at the end of this function, we do not return anything, and also, we return to the main without data, so to say. And then in the main function, we work with our original variables x and y. They are not modified during this process because we just modified those variables which are different. And this is the case why the x and y variables in the main function are not changed in this case. Okay.
Yeah. I think we haven't got any suggestion why it could be a compiler error, but then just let's continue. And what you've mentioned brings us to the next topic, which is the scope and the lifetime of variables. It's a very crucial concept, not only for the C programming language, but many other programming languages. And I hope I can also answer some questions that have been asked in the chat before. So for example, why we don't have to specify the data type for original points in the increase points function. I hope we will cover and discuss that now. So if we have a look at this code snippet here, so we have again the increase points function and the main function, and in both of these functions we have one variable which is called points with the data type int. Now, again, the question, is this the same variable or are these two different variables? If you like to just drop your opinion in the chat, if you think this is the same or if these two variables are different.
Basically the same question as before, with the difference that here this points variable is not a parameter, but it's a local variable within this function. This is the difference. I think most of you got it right.
So it's definitely a different variable. So we have this variable here which has the value 100, and we pass the value of the variable but not the variable itself to increase points. There it is stored in original points, so we have the value 100 stored here in this parameter, so in this variable that is used in increase points. And just because they have the same name here, so this variable points here and this variable points in the main function, they can have the same name, but they are completely different variables. They can have different values, and we will now see why this is the case. So when we talk about scope and lifetime of variables, we mainly think about three things here. So first of all, it's the scope, which defines the area, so the region in a program, so in your code that you've written, where one specific variable is available or not available to use. So there are some regions in your code where you can use a variable, but there are also some regions in your code where you might not be able to use your variable. Similar to that is the lifetime. So when you create one variable, most of the time the variable doesn't exist forever. So at some point, the variable won't exist anymore in the memory, and then the lifetime of this variable ends. So usually every variable has a specific lifetime, so once it is declared until it is not used anymore or not available in the memory anymore. And which is quite similar to scope is the visibility. So scope is really about the area, so the region within the code where the variable can be accessed and used. But there's also visibility, which means, okay, it is a code region where this specific variable can be really accessed. We can specify a variable that might be within the scope, but for example, it's not visible. So imagine it like you're in a house, and within the house you have a variable. You know this variable exists somewhere in the house, but you're not able to see the variable, able to access the variable because it might be in another room. So the variable might be in the first floor, you might be in the ground floor, therefore you're both in the same house. So it is in the same scope as you are, but you're not able to access it because it's not visible. And for that, let's start with the scope, and in particular the local scope. So when we talk about the local scope, we mean that a variable is just available within a specific function or some specific block. So for example here, we have the variable points, which is only available in the main function. So if you would have another function here or top of that, we would not be able to access this local variable points because we can only access it within this block here. And as you have already mentioned before, if we now pass the variable to a function, we do not really pass the variable, but we do pass the value of this variable to the function. So what is passed to increase points is not this variable itself, but we only pass the value 100 as the first argument to this function here. So there's a huge difference between passing only the value and passing points, which we'll take a look at it in 2 weeks. All right, so that's the local scope of variables, and now we can return to the code snippet from just before, and we can now say, okay, these two variables here, so int points in the function increase points and int points in the function main, are definitely not the same. They are only, or they can only be used within the main function here for this variable and within this function here in the increase points function. And if you modify a value here, it doesn't affect the value here. So that's the basic principle of local variables. Yeah, we've highlighted here again, you can only use this variable in the main function and this variable in the increase points function. But it's not only limited to functions. So again, we have code snippet here with the variable health, which can be used in the whole main function, but we can also declare variables in a block. So for example, in an if block, or it can be while block, for block, or whatever. So we can declare variables in a block that's again valid C syntax. It can be compiled, there's no error message. But if we declare a variable within one specific block, then this variable is only valid or can be accessed within this particular block here. And that's when we talk about block scope. So if we would try to access it outside of this block here, we couldn't do it. We would get a compiler error message, and this would simply not work. So this means that the scope of the int lives variable here is limited to this block here. So it's limited to the curly braces and all the statements within the curly braces here. So if we would want, for example, to print the variable that is declared here, outside of this if block, we would get the error message that lives is undeclared because, yeah, we are here inside of a block and lives is not visible. It's out of scope here to print it. So we just cannot print it because we cannot access it. The outside part of the main function doesn't know that lives exists, has existed, and we cannot use it. So we have talked a lot about the local scope, and we will briefly talk about global scope. So you can not only define and declare variables in a function and use them there, but you can also define a variable outside of all functions, for example, at the top of your program, of your code. If you do that, then you will be able to access this variable in all of the functions that you use. So for example, if you define the variable lives here, then you can access this variable in the increase lives function, in the decrease lives function, but also in the main function. And in this case, so when we are talking about the global scope and global variables, if you modify the value in one of these functions here, then the value is also modified if you use it in another function. So the changes are globally. Once you modify something, this also affects all the other occurrences of the variable. And yeah, we just briefly talk about global scope and global variables because we don't want you to use them in ISP. This has several reasons, but mainly, or the main reason is that you can change the value of a global variable by accident, for example, and then the rest of your program doesn't work anymore. So global variables can be helpful, but especially when starting to write code, there are a lot of pitfalls, so there are a lot of possibilities for side effects, for unwanted side effects that can affect the behavior of your program, and that's why you are not allowed to use global variables in ISP, so in this course. So we are just using local variables with all the nice features that we will talk about in the next weeks, and we don't want you to use global variables at all. All right, so again, we have prepared a short code snippet on Slido, and now we want to know what is printed here. So we have two functions, the main function and the initialize number function, and we want to print the number that is initialized in the function above. Right, let's wait a few more seconds and look at your answers. Yeah, in this case, it's indeed a compiler error. Why is this the case?
Yeah, so the problem here is that in the main function, we call another function that is called initialize number. This function has no parameters, but also no return value, so it just does something and does not return anything. So in this case, there is a variable called number, but this is a local variable within the scope of this function. And as soon as this function ends, also the lifetime of this variable is over, and we then return to the main function, and afterwards we wanted to print the value of number. But what is number in our scope within the main function? It doesn't exist. So the compiler doesn't know what number here is, and therefore it's a compiler error.
Exactly. So yeah, and most of you got it correct. So
yeah, sounds good.
I hope. Okay, perfect. Then let's take a very brief look at loops again. We have talked about it last week already, and today we have prepared another example. We want to print a countdown, for example, as in cinemas or movies. So how could we do it? We have prepared a code snippet here and just briefly go through it. It's a function called countdown. To this function, we pass an argument, so this is stored in this parameter here, and we want to print all the numbers. For example, it's 10 or 5. We want to print all the numbers until we reach 0. So we have the condition here, number is greater or equal than 0. If this is the case, just print the number and decrease it by once. Once we're done, we just return 0, and that's all that's happening here in this code snippet. So let's take a look at all of the iterations that are happening here. So we have the first iteration, in this case the number is 5 and we print this number, so the output is also 5. The second iteration we have 4, the output is 4. This continues for all the other numbers until we reach 0. So once the number is 0, we print 0 and we are in the 6th iteration. So we just decrease the number and print the number. And in this case, the loop runs 6 times, or in other words, it runs 6 iterations. And we can describe an iteration as a repetition of a set of instructions, so a set of statements here in this while loop, using loops until a certain condition is met. So if we take a look at these 3 components here, condition, so we have the condition number is greater or equal than 0. Using loops, okay, we have a while loop, and we have a set of instructions. So we have these statements in the while loop, which means that if we do something iteratively, it means that we repeat something until some condition is met or not met, or we specify it. But there is not only an iterative way to do this, to print a countdown.
Sorry, one question was raised. Why does the program knows that it starts with 5? So in this example, we just assume that this function is called with 5. Then, number is initialized with 5, so the first iteration is 5 and so on. But we also could have called it with 10 or 100 or whatever. So in this case, this is just an example where we call this function with 5.
Yeah, that's a good point. Thanks for pointing that out. We just assume that it's a call from the main function, for example, where we pass 5 to the function. So yeah, we have the iterative way, but we could also do this in a recursive way. And that's why we'll have a brief look at recursions today. Just a bit of the theory. If we use a recursion, or a recursion in general, means that we call a function within the same function again. We will have a code snippet for that on the next slide, so don't worry. Sounds like magic that we call a function within the same function, but we will have an example for that. So when should we use the iterative approach? When should we use the recursive approach? This really depends on the problem that you have. So both the iterative approaches and recursive approaches have advantages and disadvantages for some problems. There might be a difference in the lines of code, but also in time and memory complexity. There are a few advantages of recursions for specific problems. Some of you may have heard about the stars of Hanoi or the calculation of the Fibonacci numbers. So these are very good use cases for using recursions. But recursions are also heavily used in different search algorithms, but also in sorting algorithms. I think we will also cover that in one of the following lectures. And recursions can also be very useful for specific data structures. So for example, if you have a binary tree, it's just one of many data structures. It's quite a best practice to use recursions to iterate through all of the nodes that you have, for example. So there are there are use cases where recursions are the better option, but of course you shouldn't always use recursions for every problem that you have.
Yeah, as you said, there are use cases where iteration is for sure the better option, but in some cases, recursion is the better way.
Mm-hmm. And now let's print again the numbers for our countdown, but now using the recursive approach. So what seems a bit strange here is that we have the function countdown and we call the function countdown in countdown again when returning something here. That's really strange, but it works actually. So let's go through this example here. Whenever we have a recursion, we have to specify a base case, because otherwise, if we do not specify a base case, again, we have an, as before, infinite loop. Okay, this will call itself again and again and again and again until there's no memory available anymore, and the program crashes or the computer crashes. And that's why we need to have a base case, which says, okay, we have now reached the base case, do not call the function again anymore, but stop here and we'll go back. We'll see this very soon. So we always have to specify a base case to avoid an infinite call of the function, and the other case is that we have to call the function again, so the own function, because otherwise it wouldn't be a recursion at all. All right, now let's go through this. Let's print again the numbers 5, 4, 3, 2, 1, and 0. We start in the main function and call countdown with the value 5. So we are entering this function, int number has the value 5, we print the value, so we print 5, we check, okay, number is equal to 0. No, that's not the case, so we do not meet the base case. But instead, we return countdown number -1. So this means we return the value of the function call with the value number -1, so we decrease it by 1. So we pass the value 4 here again to the countdown. What happens here? We print 4, so it's 4, the base case is not met. Again, we return countdown, so the function call with, in this case, 4 - 1, 3, so we print 3, the same for 2, 1, and now we reach 0, so 0 is printed. But now we enter the base case here, so number equals 0, which is true in this case, and instead of returning the value of the function call here, we return 0. And now it becomes interesting what's happening here. So we return 0 to the previous function call, so the function call with the value 1, the same for the function call with the value 2, again we return 0, the same for 3, 4, 5, and this is also done for the main function. So what is in the end returned to the main function is 0. In this case, the return value doesn't have any effect, but we could, for example, use the return value to calculate something. We could, for example, calculate the sum of all the numbers. So there are, or most of the time, you will have some use cases if you use functions where you will need the return value and do something with the return value. So it's not only printing all the values, that's great, but most of the time there is a particular reason to use the different return values that are used in the recursion.
Yeah. So the code of a recursion is often smaller than the one with the iterative option. But as you can see here on the right side, here could be the problem. So imagine if you have not just 5 calls, but 1 million calls, for example, then it could be a problem, because if we go back to the first one, so where we call this function with 5, until this call is entirely finished, we call the function again with 4, and until this call is finished, we do another call, and so on and so forth. And so we have many function calls that are not entirely finished so far, and each function call also needs some memory space, and this could then cause some problems when you have, for example, 1 million function calls that are not finished so far, compared to the iterative version where this wouldn't be a problem, because you just iterate through the numbers and just print always the value, for example, without needing that much memory.
Yeah, that's a good point. So the main function is waiting for the count on 5 function to return something. Count on 5 is waiting for count on 4, and so on. And in this case, main has to wait until we reach the base case. And as you said, if this function, for example, is called millions of times, this could be a problem. Okay.
Okay. Then let's come to the next concept, which is constants in C. And here we start with an example, and as you can see on the left side, we have a code that uses here the value 42 as a comparison value with this variable that is first entered by the user. So the user enters some value, and then this value is compared with 42. And as you can see, we have in our code here this value as a constant, and in C we have the opportunity to define constants with a name. So we use the define keyword followed by a name that we can choose for the constant, and you can see we write this in uppercase letters with underscores between words, and followed by the constant. And afterwards we can use this similar as variables in the code, as you can see here. And in the end, these two code snippets would work the same, so the output would be the same. The difference between such constants and variables are that such constants do not need memory, but variables, so like this, does, because they do need memory for sure, because an integer needs space in our memory, but those constants do not. Why is that? Because when we compile our program, the predecessor does something like, it's similar to find and replace. So it goes through our program, and wherever we use the answer, it changes this word or this value to 42. So it's more or less a find and replace before the program is really compiled. So for the compiler, in the end, it doesn't make a difference. It's just a better way for us to define constants. And whenever we have some constants at one place, for example, at the beginning of the program, we have a better opportunity to maintain our program, to change a value at one point, and whenever we use the answer, it gets changed at every point. So this is also something where we can avoid to have some mistakes in our code. For example, if we would use 42 more than just one time, then after, for example, we want to change it to some other values, and for example, just do it 2 times that we correct it, but once we omit it, and then it stays 42, which would be an error in this case. So this can't happen when we define it just once as a constant. So what is happening, as I said, the pre-processing happens, and then all the constants are found and replaced, so to say. So for the compilation part, it doesn't make a difference.
Yeah, and since you've mentioned these two phases, so preprocessing and compilation, we will now have a short look at the compiler. And first of all, we will take a look at how our programs are stored in the memory. So this is actually how a program could be stored in memory. So it's only zeros and ones, which is, at least me, and I think for most of us, quite hard to read and also hard to write. So we don't know what's happening here. We don't know what all of the zeros and ones mean. So it's definitely better for us to just write code in C or other programming languages, but in this case in the C programming language. And we can just write code with the syntax that we know in C, and this is somehow translated to machine code, so to zeros and ones, so that a computer can understand it and can execute all the statements that we have written using C. And the magic part that we use here is something that I think most of you have heard now already a few times. It's the compiler. So the compiler translates the code that we have written in C into a machine code that can be understood by a computer and therefore can execute it. So if we now take a look at the phases of the compilation of your program, we start with the source code, which is written in C, and we have the preprocessor phase that you have already mentioned. So for example, all the constants that we have defined are replaced in the code with the actual value. We then go into the compilation phase, which produces an assembly code. So don't worry, we will not work with assembly code in this lecture here, but for most of you in your further studies, there will be a course where you will deal with assembly code. So this code in C here is the same as the code in assembly here. So we can still read some parts of it, but it's definitely not as convenient to write as in C.
A little harder to understand, but it somehow makes sense. And yeah, for sure, yeah, you will hear about that in another lecture.
Yeah. And now we have simplified a bit. Once we have the assembly code, there is also the linker, which includes headers, for example. And in the end, we have a machine code, so we have zeros and ones that are produced using the assembly code. And now this is the thing that we can run, that we can execute, and that's what also understood by the computer when we execute it. So how can we now convert the source code in C to a machine code which is binary code, which is just zeros and ones? For that we can use a compiler, for example Clang, but we could also use GCC. But for this course, it's definitely a good option to use Clang. So we just say, okay, Clang my code C, which is a file containing C code that we have written. And we could also add flags to that. So there are a bunch of different flags. You can also take a look at the makefile in the assignments, in the repositories that you will get. For example, one flag that's quite useful is the WALL flag, which means show me all warnings in my code. But yeah, there are a lot of other flags. This is just one. Now, if we want to create a file that is readable by a machine, by the computer, we should add this option -o, so output, and the name of the file makes sense to have a similar name as the C file. And this is what really produces a file that can be executed, that is readable by the computer. So whenever you want to compile your C code or your file that contains C code, you can use, for example, this command here. So clang, in this case, use the flag WALL and then -O and the name of your program. If you want to take a look how this program really looks like, so how it is stored in the memory, you could, for example, use xxt. It's a command in Bash that you can use, and using the -b option, you can show or display your program in a binary representation. So this is really the binary code, so the zeros and ones, how it is stored in your memory and how it is understood and executed by your computer.
But not really understandable for humans.
No, yeah, at least for most of us. Yeah.
Yeah.
All right. And if you want to just execute your program, so I think this is the option that we usually want to, so we don't want to have a look at the machine readable file, but we want to execute this file. And this can be done by just writing // and then the name of your program that you have used when compiling your program. And yeah, when you run this program, it will just execute all statements until the program is over, and yeah, you can use the bash, for example, after that, whatever you want to do. Okay, and this is how we can execute binary files. It's also important that you try at least once to compile your file or your code manually. This is also a part, or can be a part of the assignment interviews, to be able to compile it manually, so not only using makefiles. And this is the most basic option to compile and run and execute your program. All right, and now this already brings us to the conclusion. So we covered a lot of topics today, mainly focused on functions that can be used to decompose one huge problem into smaller sub-problems. So we can have something complex and break it down into less complex tasks, so that we can manage them easily and also reuse the function that we have defined, so we don't have to duplicate code. Yeah, if we use functions, we should always take care of the scope and the lifetime of variables, which means that not every variable that you have defined somewhere in a function is available in another function, but also passing variables or values of the variables to other functions do not, or changes do not affect the variables that, for example, are in other functions. Yeah, we also had a brief look at recursions. So what are the differences between iterative and recursive approaches? For some problems, recursions are quite useful, but most of the time for this course, the iterative approach will be sufficient. Yeah, very important to not use global variables in ISP, otherwise you will get a lot of points deducted at the assignments. And what's also a good thing is that you should use constants, so do not have hard-coded values in the code, but use constants in the code that are replaced by the preprocessors, by the compiler. Definitely avoid mistakes, because if you want to change the hard-coded value at one point but do not change it at another point, yeah, you will have a behavior that you don't want to have. And we also had a look at the compiler, the simplified version of the compiler, to compile C code, which is quite high level, into a machine readable program that is then able to be executed by a computer, by a machine. All of this is then done by a compiler. All right, yeah, if you have any questions, wait for the next stream, or actually it's not the next stream, so
yeah,
it's
live in the P1 next week. So we do not have the stream, but we will have the recording at least a few days later.
So yeah, this is the last live stream here on YouTube for this semester. We will now, as I said, switch to the lecture hall P1. Of course, we will record all the lectures and upload them to YouTube a few days later. But we would be happy to see you also in person in the lecture hall P1. And yeah, if you have other questions, just check the course website, especially the FAQ section. Also raise them on Discord if you have any. We're very happy that our tutors are actively answering all your questions. So I think Discord is the best option to ask questions. And of course, don't forget to do the weekly exercises in Teach Center, not only to avoid point deductions for the assignments, but to practice coding, getting familiar with writing code in C. All right,
okay.
I think
that
we are done for today.
Sorry, so we are a little bit over time for today, but yeah, we'll hope that we'll get it on point next week again. So yeah, see you next week in the lecture hall P1. Thank you for joining.
See you next week. Thank you.
Thank
Bye.
you. Bye.